Of course, I just stumbled over the word architecture and not hexagonal. But there's the pronunciation. I stole it because Sean McCool gave me a link that actually said it for you. It was like hexagonal. Hexagonal architecture. So a little bit about me. I'm this guy with a huge weird face on Twitter. I covered up my eyes because that's just so bizarre to stare into these eyes. They're kind of like staring into your soul, sending mind bullets. It's good. Fidao on Twitter. I work at Userscape. I primarily work on HelpSpot. If you know, we've talked about Snappy a lot. HelpSpot is also there. Yes, it's there. It's a thing. It's still the biggest thing. I bring home the money. HelpSpot's a self-install app. It's also a customer support application. So if your data is important to you, you don't want it on a SaaS app, HelpSpot is kind of like the application for you. And some code examples I use later are going to be part of a customer service type app, just for some examples. I'm Chris Fidao, author. Rebecca and our team took this picture on Tuesday. It's awesome. I'm actually the guy in the background. Vaprobash, Vagrant provisioning bash scripts. Who uses this thing? Yes. Vaprobash, I intentionally make simple. I have a list of bash scripts that you can turn on to use to install things. And you can always look at the bash scripts and copy and paste and steal that and actually learn what all these things are doing behind the scenes. I don't like too much magic. You don't learn when magic is there. This is why Rails application developers don't know what's going on behind the scenes. I hope I don't get flamed on Twitter for that. We'll see. Servers for hackers. Who's signed up for this? Everyone, right? Everyone? Oh, yeah. Newsletter comes out every 2 weeks, where I basically write kind of a blog-style thing on a topic or two. It's all servers is geared for developers instead of neckbeards, instead of DevOps peoples, or instead of system administrators. So it's very PHP-oriented. The topics are kind of simple. All right, so there's actually a talk I'm going to do. It's not just self-promotion. So I'm going to talk about why we talk about architecture, and then I'll talk about what hexagonal architecture is. I'm going to talk about this concept of ports and adapters, which is another name for hexagonal architecture. And then boundaries and layers, because it's a layered architecture and there's boundaries between each layer. So on a Laravel I/O podcast recently, I asked the guys why we care about architecture. Sean had a great response saying, I'm sorry, Jeff had a great response. Everyone did, but it was really about kind of like reduction of stress. It's why we try to make our code good. It's why we try to make it changeable in the long run, right? It's a long-run concept, maintainability. We want to keep our applications maintainable so that we can make changes. We want to make changes easy for ourselves, and we want to make changes easy for ourselves in the long run. So if we have an application that's going to last for more than a few months, like in the time span of years, we want to be able to always make changes. And part of that is this concept of technical debt. Technical debt is just like maintainability. It's the ability to change things. If you have low technical debt, you don't have to pay a lot of debt in order to make changes, to fix bugs, to refactor things, to add features. So when you make any decision in your application, you're adding technical debt, right? So we start at a blank slate, but then we decide to use a framework, Laravel. So we have some technical debt there because we're working within the confines of Laravel. We'll use Postgre or MySQL or SQL Server or something. That's more technical debt because you have to work with that infrastructure. So that's all good. We have this baseline technical debt. You can't get away from it. But then we start coding. And at the time we start coding, we see that we have a lot of decisions to make. We can just start laying down code and making things work. But any bad decisions you make to start are really going to bite you later, right? So if you make terrible decisions to start, later decisions and later features and functionality have to build on top of that, around that, whatever the case may be. And so you see this exponential growth curve of technical debt. It's kind of picking the nose of the Jolly Roger here. You don't want that exponential growth curve of technical debt, because then making changes is impossible. Bug fixes are hard. Adding features is difficult. Everything's a workaround, and nothing really works the way it should. What we want to do is keep this linear growth curve of technical debt. It's not a curve, it's straight, luckily, or hopefully, I should say. So you want to keep your technical debt low, and it's always going to grow because you're adding features, adding more code. But you want to keep it as low as possible so that you can always make changes when you need to. That being said, what is hexagonal architecture? So I'm going to give you a description of it, not a prescription, right? I'm not going to tell you this is hexagonal architecture, this is how you code. This is kind of a description, and it's a mixture of things like how I see it, and kind of how I code in a way that I think is in line with what hexagonal architecture is. So what is hexagonal architecture? I haven't actually said it. It's a way to decouple your code within different layers. It's a way to encapsulate variances, so a way to encapsulate what changes in your code. Because once we encapsulate the things that will change, they're easy for us to add on to change, to fix, whatever. And part of that is also ignoring the stuff that stays the same, because the stuff that stays the same, that's not going to change, doesn't have to be written in such a way that's easy to change, obviously, right? So a hexagon, the hexagon, it's layered. We have 3 layers, roughly, or more than that. I'm going to go through each of these layers, but we have outside stuff, and we have inside stuff. Each layer has outside stuff and inside stuff. So like the application layer has a framework and a domain layer outside and inside of it. So I'm going to go through each layer. And then I'm going to go through each layer again. And then I'm going to go through each layer again. So hopefully you'll get what I'm talking about, maybe. So core domain, right? I have 2 things here, a core domain and a domain layer. I hope my pacing isn't weird. I just thought of that randomly, but I pace when I talk. All right, so core domain layer is like your business logic. This is stuff that tells your application what to do. This is stuff that makes your application your application. And then inside of the domain layer also is stuff that supports that, but it's also part of your core domain logic, which I'll get into also. Oh, cool. So the domain layer has behavior. This is part of your domain logic, right? We have behavior, what our application does. And we have constraints, what our application cannot do. Both in terms of what the functionality, like the business logic is, like our application cannot delete users, maybe. You know, some might be some use case. That's a constraint. Or also in your code, the developer does not have a code path to delete users. Because then they don't accidentally make some script that will delete a user when the business logic says, you know, you cannot delete a user. So outside of the domain logic area where we have behavior and constraints, we have the application layer. The application layer orchestrates the use of the stuff in the domain layer. So we talk about that in controllers a lot. Here I have it in this kind of pseudo application layer. It's still part of our code. It's not, I mean, it's not the domain layer, but it's still our code, right? It's the application layer. It orchestrates what happens in the domain entity. So if you create a new user, it's going to orchestrate all the steps you need to take to do that. The framework layer, I call it the framework layer, but it's really any code that's not yours, like stuff in your vendor folder. It's Laravel in this case. It's all your code that helps you do stuff, but it's not your application. So hexagonal architecture is also called the ports and adapters architecture. I actually looked at this slide. I'm up ahead one. We have the outside also. So jumping back a second. Outside of the framework layer, we have the outside layer, right? So HTTP requests, the various SQL servers we could talk to, or NoSQL, APIs, clouds, other hexagons, other applications. So that's the stuff outside. That's not any part of our application, but it communicates with our application. All right, so now we talk about ports and adapters, the other name for hexagonal architecture. I'm just checking the time. Cool. All right. Ports and adapters. Every layer here is an adapter for the layer inside of it. So we have HTTP requests. Laravel, the framework, in the framework layer, is adapting an HTTP request to code, like to a controller. And then that'll go into an application layer. Right? The framework is going to use stuff in the application layer to perform some kind of thing on the application, like creating a user. It's going to have the code to do that. So we have this notion of ports and adapters. A port would be like HTTP request. The adapter would be like the framework layer adapting that to code. Once again, we see this concept of inside-outside, right? So an HTTP request comes in. The framework changes that and makes it a controller. So we have a code format, a code representation of that HTTP request. And then we have this concept of CommandBus. I'm really thankful for Sean and Jeff and anyone who's mentioned the CommandBus because I have less to explain. The CommandBus will create a command, a use case, or whatever your equivalent is in your application. And that will use a use case from the domain layer, and the application layer, the handler for that command, will do all your stuff to create a new user. It's the example I keep going back to. Similarly, we have stuff going inside out. So like the domain might fire a domain event, so we create a new user. We fire a create new user event. That gets pushed out to a dispatcher in the application layer. In the framework layer, we have our service implementations, like the listeners to those events that might send an email or send a notification or something like that. Can you pass me that water? Thanks. My mouth is super dry. So this all has an implication, and that implication is the flow of dependencies. Dependencies should go from outside in, right? So the outside should depend on the framework. The framework depends on the application layer, because without the application layer, there's nothing for the framework to do. The domain needs to rely, the application layer needs to rely on the domain layer, because without the domain layer, there's nothing to orchestrate. So we have this idea of dependencies going from the outside in. So this is kind of easy to think of when you're thinking of a data flow going outside in, right? HTTP request depends on application, or depends on framework, depends on application, depends on entities and domain layer stuff. Going out is a little more awkward, right? So if our application layer needs to send a notification, it's going to choose an implementation. So say it sends an email through Amazon SES. In order to send a notification, our application now needs Amazon SES. So it's relying on something outside of it, right? The application layer sends a notification. The implementation of that is in the framework layer. So how do we invert that control? And of course, I'm going to talk about inversion of control. This concept where we use interfaces to invert the control so that the framework layer will rely on the application layer. The application layer will tell the framework how it has to behave. So if our application layer defines this interface, the notifier, our framework layer has to implement that to send a notification. So we have this inversion of control here, right? The application layer is saying, this is how you're going to send a notification. You can choose your own implementation, but you have to do this. You have to have the send method. It has to accept a message. So this brings me to use case-driven development. OK, let me step back a second. So that example of the notification, this is an example of decoupling between the layers, right? So we have the application layer not depending on the framework layer because it's more decoupled. It just has an interface, and the framework implements it, but it can change implementations, right? So we've encapsulated a change there. We can use SES, we can use Mandrill, we can use all this stuff. We could actually use Laravel's mail library and then just change implementations in that. And this brings me to use case-driven development, which is a term I sort of coined. I don't think it's an actual thing. Also, Portal is an awesome game. So use case-driven development is another way to encapsulate stuff. It's another way to decouple layers, right? So if you think about it, we have all these contexts in which our application will get requests. Of course, we have a web request, and APIs, which are all HTTP, right? So those can all go to a controller or a closure, whatever. But we also have command line stuff. Commands is a way to use our application. And then we also have queues and event handlers and just other stuff, right? These are all ways our application can be used. A queue job could fire off a worker, and that worker will perform some function on our application. And that could be anything, right? That could be like something big, like creating a new user somehow, possibly. Or it could be something small, like resizing an image. And event handlers are the exact same thing. They might just send an email, or they might do something large in our application, even though it's an event spawned from some other event. But we have all these use cases, all these contexts. And if we have a use case, if we have these commands, then we have code that we can reuse in every context. So this is decoupling your application from the framework layer because you have these set paths of execution on your application, right? You have a command, create new user. You have a command, delete user or update subscription plan, right? These are the only ways your application can be talked to, can be used. And within all these contexts, web, CLI, HTTP, whatever, you're still confined to these certain use cases. So your application is in control right there. And then you have this decoupling so that you don't have to rewrite code in a controller and then do almost the exact same thing in a job handler for your queue, right? And this is the command bus that we've seen. A command bus takes a command. It grabs a handler and tells the handler to handle that command. So we've seen this code pretty much already. This is like a simple command bus implementation. Executes command, gets the handler, does the handling. Right, so here we have just a review. So we have outside and inside. We have a web request going to HTTP. The command bus handles it. It grabs a use case. And then we have events flowing outward in the outward direction. We have events going to a dispatcher, and that might send like a notifier, an email, something like that. But we have this decoupling, right? So what I'm trying to describe is how we're not coupled to each layer. We use interfaces, we use use cases, whatever, to make it so that we can change stuff easily, right? Because it's all about maintainability. It's all about low technical debt. OK, so I mentioned I work at Userscape. I work at HelpSpot. I work on HelpSpot. HelpSpot is a user customer support application. It has users, staff, and you can make requests or tickets, same thing. And then there's this notion of categories where requests and staff both have categories, and the staff can only handle requests of certain categories. And I'll get to that in a little bit. Boundaries. So between each layer, we have a boundary. And this boundary is kind of like the thing that tells other layers how to adapt to that layer, right? So that's really our interfaces. So at the boundaries, what we find are interfaces. So the domain layer is going to define interfaces to tell the application layer how it can be talked to. So in the domain layer, we find the command bus interface and a handler interface, for example. And that's going to say, it has an execute method, it has a handle method. The application layer has to implement these in order to use me being the domain layer. Right, so use cases, repository. This is why I interface repositories. I like having while we never really changed databases or data sources really at all, I like to interface repositories because they're a little more testable that way. You can mock them out. And that's really it. I'll get into testing a little bit. Testing is not the end-all, be-all of this. I won't even mention it that much. But we have use cases like commands. We have a repository interface. We have events, and the application layer actually handles the interface for that, but there are events there. That's actually shouldn't even be in the slide. Whoops. All right, example ticket repository interface. Don't worry about the code. I just have an interface for the reasons I described above, mostly testing, because Eloquent abstracts our database away so well that we can switch data sources really in reality, and we still never do that. Has anyone actually changed a database? And like, has that been useful? Somebody has had Eloquent and they changed from MySQL to Postgre? There are no hands up. Oh, there's one hand up. There's two. OK, fine. 3. Good. All right. That's interesting. Nobody does it. If it's 3 out of 270. All right. So we have this boundary, another boundary, application and framework boundary. So again, where are our interfaces? How does our application tell the framework how it's going to be used? Stuff I've already covered mostly. The notifier interface is here. The validator interface is here. I didn't really talk about validation, but of course Laravel has a great validation library, so why would we code that ourselves, right? So we have an interface. Our application is going to validate some stuff, our application layer. And it's going to use Laravel's implementation of it. Same with the dispatcher, right? So the application layer, while determining when events are dispatched, can make use of Laravel's dispatcher, so it doesn't have to code its own. But you're not coupled to it because you use this interface. We've inverted the control. So the application layer can dispatch events, but it can use any event dispatcher you have, Laravel's or whatever you bring into your vendor directory as a third-party thing. Finally, we have the framework layer, and outside of the framework layer, we have, at the boundary of the framework layer, we have all the outside stuff. And we don't care about this because Taylor has cared about this for us. This is the framework, and outside of the framework is all the stuff the framework does and all the ways it communicates for us. The framework, things like Guzzle for HTTP requests, and APIs, and all that stuff. I'll quickly mention that we have this other hexagon off to the right here, and that's because you can separate your code in a lot of ways. You could have like multiple hexagons in one application. So like maybe your access control layer or whatever you want to call it, ACL, is one hexagon, but then like another that's all about user management or maybe request management and HelpSpot would be another. And you can communicate with that over other stuff like an API, or it could be just other code that you call. But you can actually segment your applications in all these hexagons and have this really clean separation of concerns. So that way you can really kind of get teams of people working on different parts of your application. But that's really a side note. A lot of us aren't in that situation. So what am I talking about here? This is our second run through the hexagon, right? So I went through the layers quickly, and now I've gone through the boundaries and the layers. But what we are doing here is this quote. This quote is from a book. That book's name is now escaping me with 270 people looking at me. It's Head First Design Patterns. And that book made this quote, and this really was like a little light bulb over my head for me. Like what are the point of all these design patterns? What's the point of architecture? Identify the aspects that vary and separate them from what stays the same. Key point here is encapsulating change, right? So anything that changes, the kind of stuff that might change in implementation, we encapsulate that so that it's easy to change later. Fixing bugs is easier because the thing that does something is in one area. Adding features might be easier because it doesn't affect so many other areas of the site if things are kind of encapsulated. I mean, the big example here is changing, or the example I keep reusing is changing like an email implementation, because I've had to do that so much. But there's other things, like you might have to change your business logic, and that might not change your application layer, because your application layer is just this CommandBus thing and a command, and the handler that handles it, but the handler might not even need to change if your business logic is just like, when you create a user, it sends out this email instead of this email or something. But we're encapsulating change with this architecture, right? Every layer is not beholden to the layer outside of it. In fact, it's the opposite. So let's go in and actually look at some code in each layer here. This is going to be our third run through the hexagon. And I'll go through each layer inside and outside again. So the domain layer, right? Use cases, repository, interface, events, domain events, and of course the core domain, the business logic. So let's look at some business logic, the behaviors and the constraints. This is the biggest code block you'll see. Is that readable? You guys in the back? I can't do anything about it. Figured I'd ask. All right, cool. So up above on the top, we have a constraint, right? So I was saying how there's this thing with categories. If there is a request, a ticket, a customer support ticket, and it's a technical ticket, someone needs tech help, the billing staff is not going to be able to handle that. So if a situation like that arises, we throw a domain exception, right? A constraint. Similarly, we set a category, and we apply some behavior. If the billing staffer is currently assigned and we change the category to our technical category, then we just set the staffer to null, because you should be allowed to do that. The business logic says that you can change category whenever you want, and it's the business logic's problem. It's its responsibility to determine if the current staffer is able to do that, and if not, just set it to null. If you try to save this, you'll get an exception, but right now, you're good, right? You just have some more behavior to do. You have to set a category and reset the staffer. Similarly, in this layer, in this domain layer, we have events. So just like you saw before, we can raise a new created ticket event. That event just goes into a pool, an array of events, and that event can get fired off later. It's not really the domain layer's problem. All it has to know is that it fires events, raises events. So we have a command. Commands are hopefully dumb objects. Their purpose isn't to be smart. Their purpose is to say you're allowed to do this in the application, right? You're allowed to create a ticket. You can't delete a ticket. There's no command for that, but you can create one. And it's just getting data. And I have this magic method to get the properties out of that and whatever. You can do whatever implementation of this you want. All right, next up, the application layer. CommandBus, dispatcher, and implementation of the repository, the database abstraction layer. So this has to implement interfaces defined by the domain layer, right? So we have the execute method. We already saw this on the CommandBus. That's because the domain layer said this is how the CommandBus has to work, so you have to implement it. And then we have a handler. And the handler is in the application layer because it's orchestrating the use of domain entities, right? That's what I said before. We validate it here quickly. We don't have to do that there. And then save it. And in the save method, we create a new ticket. We set a category. We set a staffer. We save it. And then here we dispatch the events. So the application layer is orchestrating the use of the domain entities, right? The domain layer isn't depending on the application layer. The application layer is just using it to fulfill a purpose. Repository is implemented now. Get staff open tickets. It's using Laravel database. Sweet. And the framework layer. So the framework layer is where we get some fun stuff done, right? Because it's like where all the tools are that we get to use. So we implement stuff the application layer needs. The application layer had that notifier interface, and it just implements it here. SDS, Amazon, I'm sorry, Mandrill, whatever. And of course, there's controllers. So our controller can be kind of this simple. It creates a command because we are doing a create ticket. So an HTTP request wants a new ticket. It has this data. Our controller doesn't care about anything. It just knows it grabs this command. It does the input all, and it executes it. Listens for exceptions. And I like exceptions because they're here and really only here at this top level. When you get an error in your application, a validation error or like a domain logic error, those all bubble up to the top level whose responsibility it is to handle exceptions, to handle exceptional behavior. And that's why I like exceptions. It kind of cuts through these layers. I don't have to have exception handling code in any other layer of my application except for this outer layer, who is the layer that really cares. OK, so we implemented the email interface here, and we're doing Amazon SES. This is before I was looking at Laravel 4.2, so which actually talks to Amazon now, right? No, okay, I'm sorry. So here's an SES implementation. SES uses a lot of arrays, and I try to clean that up in this code here. It loves arrays. Dispatcher. So the framework is going to be our dispatcher. In the case that I like using Laravel's dispatcher, I find no reason to bring another one in. And it's going to get the events. It's going to roll through them in an array. It's going to fire them, maybe pass it some data, whatever. It's dispatching it. Our application layer doesn't care what implementation of dispatcher it has. It just cares that it has one. So the framework layer is not coupled to the application layer in this case. Or I should say the application layer is not coupled to the framework layer. Cool, OK. Test-driven development is dead, right? Dead. So I hardly talked about testing. I brought it up. One of the things DHH says, and I will never, ever remember his real name other than David. I don't know what that is. One of the things he said in a talk he did like a quick half-hour video cast. And he specifically says hexagonal architecture, because I think in the Ruby community, one of the reasons why hexagonal architecture is espoused is for testing, right? Because if we're decoupled from each layer, we can switch out something and test it, right? We can mock it because it's so easily switched out to something else. It's all interfaced out. You can mock it. And so it's like testing, testing, testing. It's the only thing that matters. And testing is good. If your code is testable and it has tests, then it's loosely coupled, usually. But what I care about is maintainability and low technical debt. We have to work on these applications. We have to make them work. We have to add features and fix bugs and all that stuff, right? So TDD is dead. Doesn't apply in my point of view because, I mean, it's not dead. That wasn't really his point anyway, right? Testing is very much alive. Test-driven development as well. But hexagonal architecture isn't about testing, although testing is a component of it, right? It's about keeping our applications maintainable. And other myths, right? So some people say it lets you switch out your framework. Who is ever going to switch your framework? The only thing I've heard about is what PayPal switched to Node from Java. That's not even a framework change. That's just infrastructure change. Right? So I'll show this quote one more time. Identify the aspects that vary and separate them from what stays the same. I also say encapsulate change, right? So we want to always be able to change our applications. Keep technical debt low, keep maintainability high, mostly through the use of interfaces because interfaces are points of change. And then this also lets you communicate through layers of your application. The domain layer needs to be used by the application layer, needs to be used by the framework layer, and communication needs to go vice versa. The framework layer uses the application layer and uses the domain layer. Right? So we've encapsulated change in each layer, and we've made our applications maintainable because all the change is encapsulated or something. I don't know. That's it. You have time for questions? Yeah. Cool. I hope your questions aren't hard. I don't know the answer. Yeah, you. What do I think about coupling my entities to Eloquent? Yeah, active record. That's fun, right? The more you research architecture, the more you kind of butt heads with active record. But then again, you're also kind of end up in this state of mind where you're being a little bit too much of a purist. Because you just have to. Oops! Oh, this is interfering. I have my mic in here. You don't have to. You just have to make your code work. You're making an application. You might be running a business with it. Your customers don't care about this stuff. You have to make the code work for you and not be a slave to your code. You can't worry too much about that because you are coupling it a little bit, right? So Eloquent is nice that it's so easy to use. And our active record pattern is kind of doing a dual role of getting data and also being an entity, a business logic entity. So if you get into it, maybe you might decide to use some kind of entity mapping database access, where you have these plain old PHP objects, these POPO objects. But giving up Eloquent kind of sucks because it's so powerful. So I tend to just use Eloquent, right? It's just, there's a little bit of binding there, but it's not huge. You can get over it. You can use mutators and stuff. Jeffrey Way has a great video on that. Is there anything else? Sean?
Do you think that the argument about switching out your framework is really fair? Like, maybe people are going to switch out their framework as if it's only one thing and not a wide array of components, any of which you might choose to independently.
Right. So the question is it a fair argument? Is it too much of a blanket statement to say switching out your framework is a thing you can do? Whereas you can, in reality, are more likely to switch out components the framework uses and grows to, new features and that kind of stuff. And that is a great point because I actually meant to say this. Thank you, Sean. You're not likely to ever switch out your framework. You might just start a new project instead. But your framework can change and grow, add new features. It can change how stuff works. It could break. It can make breaking changes. So this decoupling makes it easier for you to grow as your framework changes, right? You can keep updating Laravel to 4.1 to 4.2 and all the stuff that's going to happen in the future. And that'll be easier because the coupling isn't there, right? You don't have to worry about controllers going away because they're not in FAD anymore because MVC is dead. Right? It's decoupled, so you just kind of adjust where you put your commands. So just whatever. You can switch out to Amazon for email, right? But you might want to send text messages, so maybe you'll use a different library to send text messages, like Twilio. That's really easy now because everything's decoupled, right? So you're not switching out your framework, likely, but you are switching out the implementations in your framework layer, right? And if the framework changes, you can kind of adjust to it more easily. That's the hope. Anything else? Yeah.
So where do you find yourself putting most of your domain logic? Do you put it into development models, or do you create other classes in like the main folder, tracers, classes?
Mostly all of that. A lot. I try to do in the Eloquent in an Eloquent model as much as I can. So one thing I mentioned before is that one of the goals is to try to make it so developers can also do things to your application that your application shouldn't do. Eloquent kind of breaks that a little bit because you're able to access the data and kind of do whatever you want to it. You can ignore the business logic I put in the Eloquent model if you wanted to. So we're all adults, so read the code and understand what it's doing. But yeah. Did I answer that? Can I get more specific? All right, cool. Yeah.
What's the URL to download your slides again?
I don't know. I'll put that up. It's on Joined In. I actually meant to put that in. It's in my notes to self, but I apparently ignored my notes to self. I'll have that up, and I'll tweet about it and everything. Anybody else? Oh, Dale?
I was just wondering if my phone was up there, because I'm starting to freak out.
Oh, you can't have it back. I don't know. You might want to freak out further.
All right. Anybody else? Good? All right.
Great.
Great job.